Solid-state batteries are at the forefront of discussions when it comes to the future of electric vehicles. Imagine a technology that promises to completely change the game, making electric cars faster, safer, and more efficient. That's exactly what solid-state batteries are bringing to the table. With a structure that replaces the liquid electrolyte with a solid material, these batteries offer benefits beyond imagination, making them a remarkable evolution compared to the lithium-ion batteries currently dominating the market. These solid-state batteries are safer due to their resistance to overheating and explosions. Additionally, they provide higher energy density, more power in a smaller space, and incredibly reduced charging times, something EV drivers have been longing for. Another intriguing aspect is how these batteries can transform the consumer experience. Imagine charging your electric car in minutes, much like refueling a gasoline vehicle. This vision is no longer a distant dream. With improved energy density, these batteries have the potential to offer even greater ranges, alleviating many drivers' concerns about vehicle range. It's like giving the industry and its consumers a fresh start. As expected, Tesla has its eye on this technology. Known for staying ahead of trends, Elon Musk's company has already expressed interest in exploring solid-state batteries for its future models. The potential integration with its already groundbreaking 4,680 batteries excites both investors and fans of the brand. After all, who wouldn't want to see Tesla leading another significant market shift? However, like any innovation, solid-state technology doesn't come without challenges. Manufacturing these batteries remains a complex task, described by some engineers as trying to glue French fries together with double-sided tape. It sounds amusing, but that's the level of difficulty involved in aligning the tiny components that make up the system. Despite this, advancements in development show that solutions are on the horizon, which is encouraging for the entire automotive industry. Beyond the technical benefits, there's also the environmental impact. With a more sustainable design and the potential to use alternative materials, solid-state batteries can reduce reliance on rare metals like lithium. This not only eases the environmental burden, but also makes EV production more accessible, a move that aligns perfectly with Tesla's vision of accelerating the transition to sustainable energy. Replacing the liquid electrolyte with a solid material also eliminates the risk of leaks and corrosion, making these batteries more durable. This feature not only enhances safety, but also extends the system's lifespan, reducing the need for frequent replacements. It's an advancement that benefits both consumers and manufacturers, resulting in more reliable and cost-effective vehicles in the long run. The market is already responding to this ongoing revolution. Companies like QuantumScape and Solid Energy Solutions are leading the development of solid-state batteries, showing promising results. As a result, the race to see who will be the first to commercialize this technology on a large scale is heating up. In this scenario, it's clear that the future of electric vehicles has never been more exciting. While companies like QuantumScape work tirelessly to overcome the manufacturing challenges of solid-state batteries, other automotive technology giants are already envisioning the possibilities this innovation can bring. Tesla, always known for anticipating trends, might be laying the groundwork to integrate this technology into its future models. It wouldn't be surprising if Elon Musk already had a few tricks up his sleeve, such as strategic partnerships or internal research, positioning the company at the forefront of this revolution. The potential of these batteries goes beyond improving range and charging times. Imagine a fleet of electric vehicles with performance equal to or even greater than that of gasoline-powered sports cars, but without the environmental drawbacks. The reduced weight and higher energy efficiency of solid-state batteries could open up a new world of possibilities for automotive design, allowing for lighter, more aerodynamic cars with increased interior space. This transformation sets the industry on a path where innovation and sustainability go hand in hand. For those following the market, Tesla's involvement with this technology makes perfect sense. The company has already proven its ability to adopt disruptive innovations, such as LFP batteries in more affordable models and the groundbreaking 4,680 batteries, which offer higher performance at a lower cost. Now, with the promise of solid-state batteries, Tesla has the chance to solidify its leadership once and for all. This doesn't just mean more sales. It means setting a new standard for the entire industry. And it's not just the average consumer who benefits from this revolution. Commercial fleets, such as electric trucks and delivery vans, are also expected to reap the rewards of solid-state batteries. The durability and efficiency of these systems can significantly reduce operating costs, making companies more competitive and encouraging even broader adoption of electric vehicles. This is an impact that goes beyond the household garage, transforming entire sectors of the economy. Elon Musk, with his ambitious vision, has already hinted that the future of electric vehicles depends on advancements like this. Recently, he mentioned the need to create larger, more versatile models capable of serving families and global markets. Solid-state batteries emerge as an ideal response to this demand, enabling the development of SUVs, vans, and even electric buses with impressive range and performance, without sacrificing weight or space. Moreover, integrating this technology could be a strategic move for Tesla in the competitive electric vehicle market. While traditional brands struggle to achieve the efficiency of current batteries, Tesla could leap ahead, offering consumers a technology that not only solves today's problems, but also anticipates tomorrow's needs. This would solidify the company's position as the undisputed leader in the electrification race. Another intriguing aspect is how solid-state batteries could influence charging infrastructure. Faster and more efficient superchargers will be required to keep up with the demand of these new batteries, and Tesla is already heavily investing in its V4 charging network. This infrastructure not only ensures compatibility with future models, but also reinforces consumer confidence in adopting electric vehicles as the definitive transportation choice. Meanwhile, the expectation surrounding the adoption of solid-state batteries continues to grow. Analysts predict that the first commercial models equipped with this technology could hit the market as early as 2025, marking the beginning of a new era for electric vehicles. For enthusiasts, this represents more than just a technical breakthrough. It's the promise of a future where performance, sustainability, and innovation coexist harmoniously, driving the industry to unimaginable heights. When it comes to strategic partnerships, Tesla has a history of surprising the market with collaborations that accelerate the development of essential technologies. Companies like Chery, which are already heavily investing in the production of solid-state batteries, could be valuable allies in this scenario. With Tesla frequently seeking solutions that combine efficiency with scalability, a partnership with experienced manufacturers in this niche seems like a natural step. Imagine the power of a Tesla factory mass-producing vehicles equipped with these advanced batteries. The impact would be revolutionary. The advantages don't stop there. The enhanced safety of solid-state batteries is one of the most appealing factors for Tesla and its consumers. Unlike lithium-ion batteries, which present risks of overheating and fires in extreme cases, solid-state batteries offer significantly safer operation. This is particularly important in markets where vehicle safety is a critical differentiator. By betting on this technology, Tesla wouldn't just be advancing technically, but also reinforcing its reputation as a pioneer in creating cars that combine high performance with peace of mind for their users. Furthermore, sustainability also comes into play. One of the major challenges of lithium-ion batteries is the environmental impact of their production and disposal. Solid-state batteries, on the other hand, promise to be more environmentally friendly, with longer life cycles and fewer scarce materials involved in their production. This aligns perfectly with the values Elon Musk frequently champions: a more sustainable future for the planet. Tesla could also use this opportunity to expand its product lineup. Larger vehicles, such as trucks and buses, could finally achieve the efficiency they need to become viable alternatives in cargo and passenger transport. After all, solid-state batteries enable greater energy density without adding excessive weight, which is essential for heavy vehicles. Imagine a Tesla Semi equipped with this technology, offering greater range and efficiency while redefining the standards of the transport industry. This strategic move would not only open up new possibilities for Tesla, but also solidify its presence in sectors traditionally dominated by internal combustion engines. The company wouldn't just be competing in the passenger car market, but also challenging giants in the commercial transport sector. With Elon Musk at the helm, it's hard not to imagine that these areas are already on his radar, ready to be transformed. Another point worth considering is the infrastructure required to support this technological revolution. Tesla is already ahead with its V4 superchargers, capable of delivering higher power and servicing vehicles with next-generation batteries. This preparation shows the company's commitment not only to vehicle advancements, but also to the ecosystem that makes them viable. This puts Tesla in a privileged position, able to offer comprehensive solutions to its customers, from cars to charging. With these prospects, the introduction of solid-state batteries into Tesla's lineup seems more than just a possibility. It's a natural evolution. The market is eager to see how these promises will translate into real products, and the expectation is that Tesla will be one of the first to make this innovation accessible and practical. More than that, it's an opportunity to redefine what it means to drive an electric vehicle. More range, fewer worries, and a truly revolutionary experience. The emerging scenario is exciting. While other companies are still trying to catch up with current trends, Tesla may be about to create the next big leap in the automotive industry. With solid-state batteries, it's not just about improving what already exists, but opening the doors to a completely new future where today's limitations become stories of the past. As Tesla moves toward this new era, an interesting detail arises: the potential impact of solid-state batteries in larger models, such as three-row SUVs, trucks, and vans. As mentioned before, Elon Musk has made it clear on several occasions that the company is not just focused on sports cars or compact sedans, but also on catering to larger families and commercial applications. This is where solid-state batteries shine even more, as their high energy density allows larger vehicles to maintain competitive range without compromising interior space or adding excessive weight. A concrete example of this application would be the possibility of creating SUVs with a range of over 800 kilometers on a single charge, even with the additional energy demands of a large, heavy vehicle. Imagine families driving across entire states without the need for frequent recharges. This kind of convenience is a game changer for consumers hesitant to switch to electric vehicles due to range anxiety. And Tesla, known for understanding and meeting its customers' needs, would certainly not overlook this promising market. Another fascinating aspect lies in the potential for commercial models. For companies that rely on transportation fleets, vehicles equipped with solid-state batteries could offer not only fuel savings, but also unprecedented operational efficiency. A Tesla Semi, for example, with an extended range and reduced recharge times, would be an unbeatable alternative to traditional trucks. This also aligns with sustainability goals, which are increasingly demanded by investors and governments worldwide. But it's not just the larger vehicles where these batteries will make a difference. Tesla also has the chance to explore new segments, such as electric vans for urban transport or even vehicles adapted for leisure, like motorhomes. The flexibility of this technology opens up possibilities for models that previously seemed unfeasible, especially in emerging markets where the demand for electric vehicles is highly diversified. This underscores Tesla's ability to innovate and shape the industry rather than just follow it. Meanwhile, more observant consumers are likely already asking, how does Tesla plan to integrate this technology into its charging infrastructure? This is where the V4 superchargers come into play, designed to support the next generation of electric vehicles. With the ability to handle 1,000-volt systems and charging rates up to 500 kilowatts, these chargers are not just an upgrade. They are a glimpse of what's to come. By creating this robust foundation, Tesla is not only preparing for the introduction of solid-state batteries, but also ensuring that its customers have an efficient and reliable charging experience. The combination of these batteries with Tesla's advanced infrastructure is an advantage few competitors can match. While many automakers are still struggling to offer reliable charging points, Tesla already has a globally established and constantly evolving network. This strengthens the company's position as the undisputed leader in the electric vehicle market, putting a vast gap between it and its competitors. With these innovations, Tesla is not just meeting consumer expectations, but completely redefining them. And of course, we can't ignore the impact of this technology on the future of autonomous vehicles. Advances in solid-state batteries could also be a crucial factor in making Tesla's plans to launch autonomous fleets and robotaxis a reality. With greater range and lower maintenance needs, these vehicles could operate even more efficiently, serving a wide range of users while maximizing profits for Tesla. With so many possibilities ahead, it's hard not to get excited. With every innovation, Tesla not only solidifies its leadership, but also inspires the entire automotive industry to accelerate toward a more sustainable, efficient, and above all, exciting future. Solid-state batteries are just the beginning of this new chapter. And by all indications, it's a chapter that will be written with the unmistakable signature of Elon Musk and his visionary team. This bold vision also extends to integrating solid-state battery technology with advanced support systems, such as the artificial intelligence and machine learning features already widely used by Tesla. Think of autopilot, for example. A higher energy density in the batteries means not only greater range for long trips, but also more power available to run sensors, processors, and computing systems that enable the vehicle to see and understand its surroundings. Imagine a Tesla Model X, equipped with solid-state batteries, continuously monitoring roads, pedestrians, and weather conditions, adjusting its driving efficiently and safely for days on end without the need for a recharge. This combination of extended range and autonomous technology creates a vehicle that not only transports but also takes care of the journey, eliminating concerns and redefining what we expect from a car. But the benefits go beyond individual vehicles. Tesla, as shown in its energy storage projects, could leverage this technology to expand its stationary energy systems. Think of Tesla Powerwalls or even mega batteries used in energy infrastructure projects. By incorporating solid-state batteries into these systems, Tesla could offer even more reliable and durable solutions for homes, businesses, and even entire power grids. This puts Tesla in a unique position to lead not just the electric vehicle revolution, but also the global transition to clean, renewable energy. After all, if these batteries can transform heavy and complex vehicles into more efficient machines, imagine the impact on stationary applications, where weight and space aren't as rigid limitations. The durability and efficiency of these batteries could make renewable energy a viable option even in remote or unstable regions. The prospect of seeing this integrated into the Tesla ecosystem is quite fascinating. With its vertically integrated approach, the company has the ability to control every aspect of development, from initial research to production and distribution. This strategy is a strong asset, allowing Tesla to implement innovations quickly without relying on third parties or being constrained by the limitations of traditional supply chains. Naturally, This approach also implies challenges, especially when it comes to scaling up the mass production of solid-state batteries. As mentioned earlier, the manufacturing process for these batteries is still complex, requiring advancements in materials and methods. But if there's one company capable of overcoming these obstacles with agility and creativity, it's Tesla. With Elon Musk at the helm, betting against this capability seems, at the very least, imprudent. And there's yet another intriguing factor: the impact of this innovation on prices. Solid-state batteries have the potential to be more expensive initially, but as we've seen with other technologies, costs should decrease as production ramps up. This raises the question: will Tesla be able to keep its vehicles affordable while implementing this cutting-edge technology? If it does, it will once again set the rules of the game, forcing the industry to follow in its footsteps. What seems clear is that we are on the brink of a significant transformation in the automotive market. Tesla is paving the way, not just with new vehicles, but with a bold vision of how electric mobility can and should be. With solid-state batteries, the company isn't just anticipating the future, it's building it right before our eyes, one breakthrough at a time. Solid-state batteries open doors to even more revolutionary applications in Tesla's portfolio, especially in larger, more demanding vehicles. Elon Musk has already highlighted the need to expand the lineup to include models capable of serving larger families or commercial applications. In this scenario, high-energy density batteries and greater safety are not just desirable, they are indispensable. Think of a Tesla Cybertruck, or even a semi. These vehicles already require enormous energy storage capacity to balance power and range. With solid-state batteries, they could not only surpass the current versions in range, but also feature significant improvements in recharge times and overall weight. A semi equipped with this technology could redefine freight transport, making it more efficient and environmentally friendly, while the Cybertruck would gain even more versatility to tackle off-road challenges without compromising range. This advancement also opens the door for Tesla to explore new global markets. In regions where charging infrastructure remains a challenge, vehicles with greater range and less frequent recharging needs could be the ideal solution. This means Tesla could reach emerging markets more effectively while strengthening its presence in already established regions. However, the real magic happens when we consider the impact on vehicle design and engineering. Solid-state batteries take up less space and can be configured in more versatile ways. This gives Tesla's engineers the freedom to create more innovative interior layouts, enhancing passenger comfort and optimizing luggage space. Imagine a Tesla Model X with even more spacious three-row seating, or a Cybertruck with additional compartments without compromising performance. Another interesting application lies in the ability to improve overall vehicle performance. With more stable and efficient energy delivery, sports models like the Tesla Roadster could achieve even more impressive speeds, while maintaining absolute control in turns and braking. This combination of power and precision places Tesla in a category of its own, challenging even traditional luxury and high-performance car brands. But the impact of solid-state batteries goes beyond the vehicles themselves. The charging ecosystem will also need to evolve to keep pace with this new technology. This is where Tesla's V4 supercharger technology comes in, promising perfect compatibility with next-generation batteries. These chargers not only support higher capacities, but are also designed to handle the more complex thermal and electrical demands, ensuring ultra-fast recharges without compromising battery longevity. And there's still an element of sustainability that cannot be ignored. Solid-state batteries, with safer materials and longer lifespans, significantly reduce the environmental impact associated with battery production and disposal. This reinforces Tesla's commitment to sustainability, solidifying its position not just as a leader in automotive innovation, but also as a company dedicated to the future of the planet. The current expectation revolves around how and when these batteries will reach the market. With Tesla's track record of surprising the world with unexpected advancements, the possibility that vehicles equipped with this technology will be ready by 2025 doesn't seem like a distant dream. After all, every step Tesla takes, whether with new batteries, cars, or infrastructure, is not just an evolution. It's a revolution that continues to shape the future of electric mobility.